Hey Algebra 1, here are the 6.6 notes for graphing inequalities in two variables. So when I give you the line 2x minus y equals 2, the first thing we have to do is get it into, for method 1 anyway, we have to get it into a y equal form. We're going to use it in method 2, we can leave it in the standard form that it is. So if I'm going to put it, if it's method 1, which is the method we talked about the other day, we have to put it in a y equals. In order to do this, I first have to move my 2x to the other side, so it would be a minus 2x here, and then I'd have to divide everything. So in this method, I'm going to have y equals 2x minus 2. Once I have that, I'm going to use my understanding of y-intercepts. In this case, my y-intercept is negative 2. And I'm going to use my understanding of slope that says m equals 2. And I'm going to use those two pieces of information to graph. The other method is I can leave it as 2x minus y equals 2. And I can find the x-intercept by plugging in 0 for y. Then I'd get 2x equals 2 or x equals 1. So I could get 1, 0. If I want to find a y-intercept, I could plug in 0 for x and get a value of 0, negative 2. But whichever way I do this, eventually I'm going to have to graph it. So with the first method, I'm going to go and start here at negative 2, go up 2 over 1. You'll notice when I do this, I get really lucky. I have an intercept of 1, 0, and I have a y-intercept of 0, negative 2. And either way, I'm going to be able to graph it. I'm not using a straight edge here, and I should be. But there's that line. Okay. Now let's make that as an inequality and use this idea. This y is less than 2x minus 2. Now, we still have the same line, but now we have an inequality. And what the inequality says is I'm going to shade some area of this graph in order to fulfill the inequality. This inequality is a little hard to see. I'll make it a little easier there. So how do I find which side of the line works? Well, let's start plugging in some points. If I plug in the point 0, 0, I'm going to just do some scratch work over here right now. If I plug in 0, 0, I'm going to plug 0 in for my x and 0 in for my y. I end up getting 0 is less than negative 2. This is not a true statement. So I put a no next to it. So it says, what 3 points on the graph make it false? Well, for sure, 0, 0, because I just found that makes it false. I'm going to put an O on here, kind of like playing Battleship. If that was a hit or a miss, it would definitely be a miss. So what are some other points that work? Well, you can pick any points on either side to find out. In this case, I can tell you right now that 3, 0 is going to be a hit. 3, 0. Let's put a little X there to denote that that side works. If I kept doing this and kept going on either side, I could find a variety of points. I'm not going to fill those in. But what you'll eventually see is based on where we're putting our X's and O's, we can conclude that the solutions are going to be all numbers to the right of our line. Alright, and the last part on here, actually let me quick denote this. If I know that it's all the solutions over here, I should probably color it in and say, I can pick anything over here, so why not color it in? There's that. Now I pick 2 on the line, y equals 2x minus 2. Are these points solutions? Well, we already have 2 points from our second method up here. Why don't we test those 2 points? Do the points 1, 0 and 0, negative 2 work? Well, when I plug this one in, I see that 0 is less than 0. Is that a true statement? No, it is not. So the point here at 1, 0 does not work. I'm going to spoil the surprise a little bit here and say that when you do this one, you get negative 2 is less than negative 2. Also not a true statement. So what this shows us is that because my line is y is less than 2x minus 2, this sign does not include the values on the line. So how do I denote this on my graph? Well, I'm actually going to denote it with a dashed line. So maybe over here, we'll say anytime I see the exclusive signs without the or equal to underneath, that's going to be a dashed line. So if I could go back and fix this one, because there is no line underneath, this should technically be a dashed line, the whole thing. So let's put some imaginary dashes in here. That's a dashed line. However, if I have the inclusive signs with the or equal to underneath, that is going to be a solid line. So if I ever ask you to graph anything like this, you're going to use a solid line. Someone also reminded me this morning that just like when we are normally graphing these on a number line, the dashed line is going to be an open circle, and the solid line is going to be our closed circle. So if that's what reminds you, if you remember that, that might help some of you, I don't know. But yeah, so if you're a method in figuring out how to graph inequalities, my suggestion is this. Graph the line, just as, graph it as an equality, make equality an equal sign. Shade an area or the other, it's either going to be the left side or the right side, the top or the bottom. Whichever one it is doesn't matter. And you're going to do this by picking points. Once you've shaded, check your line. So this means it's either going to be dashed or it's going to be solid. Make sure that if it is a exclusive, that it is dashed. Make sure if it is an inclusive, that it is solid. Alright, go do your homework. If you have any questions, let me know.